All right, today we're jumping into a really cool new research paper that totally rethinks one of the most important parts of modern AI. It's called Deep Delta Learning, and it's all about teaching these massive neural networks a skill they've, well, never really had before: how to forget. And yet, that sounds a little weird, but it gets at a really powerful question that's at the heart of this entire breakthrough.
I mean, think about it. It sounds completely backwards, doesn't it? We spend all this time and energy teaching AI to learn, to find patterns, to remember things. But what if the secret to building smarter, more stable, and just plain better models isn't just about cramming in more knowledge, but about having the ability to selectively remove or even flip old information? That's the big idea we're going to unpack today.
So, to really get why forgetting is such a big deal, we have to talk about one of the biggest success stories in AI history: the residual network, or as everyone calls it, ResNet. This thing is the reason our models can be so incredibly deep, with hundreds, even thousands of layers. But it has a hidden weakness, a little design flaw that's actually baked right into its success. Now, the absolute genius of ResNets was this idea of a shortcut. You can see it here. It's like building an express lane on a highway. It lets information from way back at the beginning of the network zip directly to a much later layer. This basically solved the problem of the signal just fading away to nothing, which meant we could just keep stacking layers and the model would keep on learning. And when you look under the hood, the whole mechanism is just beautifully simple. The new information is just the old information plus whatever new update the current layer comes up with. Think of it like a sculptor who can only add more clay. Every single layer just adds another piece, another detail, right on top of everything that came before. And that right there is the key problem. ResNets are amazing at accumulating information, but what happens if our sculptor 10 layers ago put a piece of clay in the wrong spot? Well, too bad. They've got no tool to scrape it off. The mistake just gets carried along, and more clay gets piled on top of it. In the AI world, this is called residual accumulation. It's a buildup of noise, of errors, of junk that the network has no way to get rid of. And this is exactly where Deep Delta Learning walks onto the scene. The researchers behind this paper proposed a pretty radical shift. They said, okay, instead of just thinking about adding numbers, what if we started thinking about transforming information geometrically? What if that shortcut wasn't just a simple pipe, but a really active, flexible geometric tool? This quote from the paper really nails it. They're moving away from basic arithmetic and into the much richer world of geometry. And don't let the phrase linear algebra scare you off. The core idea is that they're using things like rotations and reflections, not just addition. This isn't some small tweak. It's a totally different way of thinking about how information should flow through a network. And this formula right here, this is the new tool they built. Now, don't worry about all the symbols. Let's just focus on two things. First, this K here. You can think of K as an arrow that points at the specific piece of information we want to mess with. And second, this little Greek letter beta. Beta is the absolute secret sauce here. It's the control knob that decides what we do to the information that K is pointing at. So let's zoom in on this magic beta dial, because this is the heart of the whole thing. Seriously, just picture a simple dial that the network learns to turn, and it can turn it to a different position for every single piece of data at every single layer. And depending on where it sets that dial, somewhere between 0 and 2, it can do 3 totally different and incredibly powerful things. Okay, so what if the network turns the beta dial all the way down to 0? Well, the operator basically just turns off. Nothing happens. The information just passes through completely untouched. It's like our sculptor looking at a part of the statue and saying, you know what? That's perfect. Don't touch it. This lets the network keep important stuff safe and just skip transformations it doesn't need. Now, this is where it gets really interesting. If the network turns that dial to 1, it gets the power to forget. The operator performs something called a projection, but all you need to know is that it completely erases the information that our little K arrow was pointing at. It's gone. Our sculptor can finally take a tool and just scrape off that chunk of clay they put in the wrong place. This is the forgetting we've been talking about. But what if the network cranks the dial all the way up to 2? Then something really wild happens. The operator becomes what's called a householder reflection. It takes the information and perfectly flips it. It's like our sculptor picking up the entire block of clay and turning it upside down to see it from a completely new angle. This lets the model do some really cool things like learning patterns that go up and down. And this chart really shows you the simple genius behind it all. That one little beta dial controls the entire strength of the transformation. When beta is 0, the strength is 1. You get a perfect copy. When beta is 1, the strength is 0. The information is totally erased. And when beta is 2, the strength becomes -1, which is just the mathy way of saying you do a perfect flip. It's an incredible amount of flexibility from just one single number that the network learns all by itself.
Okay, so we've got this awesome geometric tool, but how does it actually work in practice? Well, the authors showed that this entire geometric operation is the same as a really powerful and intuitive process that you can think of as a simple erase and write.
It actually turns out that this new geometric trick is mathematically identical to a classic idea from learning theory called the delta rule. And delta is just a fancy science word for change or difference. The rule is super simple. You figure out the difference between where you are and where you want to go, and then you make a correction. It's one of the most fundamental ways any system learns.
And look how clearly this breaks it down. The whole process just makes sense. You start with your current information, x old, then you have this erase term that explicitly subtracts something, and right after that, a write term adds something new. And check it out. That same magic beta dial is controlling the strength of both the erasing and the writing, keeping them perfectly in sync. So what's the bottom line? By giving the network an erase button, deep delta learning directly fixes that residual accumulation problem we talked about at the beginning. If some layer early on introduces a bunch of noise, a later layer can learn to spot it, point its K arrow at it, turn the beta dial to 1, and just delete it. It lets the network clean up its own internal thoughts as it goes. So why is this such a big deal? What does giving an AI the ability to forget, reflect, and rewrite actually mean for the future? Well, this isn't just a tiny improvement. It's a massive leap in what these networks are capable of doing. I mean, this one single elegant idea unifies 3 totally fundamental operations: passing information, erasing it, and flicking it. It lets models learn much more complicated patterns, things that go up and down that simple additive models really struggle with. It gives the network surgical control over its information flow, which makes for much more stable, powerful, and reliable deep network. And that really brings us to the final thought here. The original ResNet gave us AI that could build these incredibly deep pictures of the world. Now, deep delta learning is giving that AI a whole new toolkit, a way to prune, to correct, and to rethink. It's a huge step towards a much more flexible and robust kind of machine intelligence. And it leaves us with a really exciting question to think about. Thanks so much for tuning in.